So, we're going to review for Chapter 3 in Algebra. We're going to do some multi-step equations. Those of you that are in my class, you're familiar with the song that I use. It's to the tune of Love Me Tender. That's an Elvis song. You're welcome to look it up on YouTube. But tune basically goes like this. I use it to review with my students. If you don't like the song, just fast forward. First distribute, then combine all of your like terms. Please remember, keep change, or you will get burned. Then get all your variables onto the same side. First addition or subtraction, then multiply, divide. So I'll be using that several times as I'm reviewing here. And we'll go ahead and get started. Number one, again, please pause the video here, try it, and see if you come up with the correct answer. There's several different ways to solve. We can do horizontally, we can do vertically. In fact, I will do the horizontal method right now. I like to draw my equal signs first so that they line up vertically. So, move it over. First distribute, no. Then combine all of your like terms. Now that indicates on one side we can't combine these. Please remember, keep change, or you will get burned. Nope. Then get all your variables on the same side. Well, it's on the same side, so we don't have a problem there. First addition or subtraction, so we're going to get rid of the addition here. The opposite of 6 is -6. Using the inverse property of addition, 6 plus -6 is 0. -8 plus -6, they join. Negative wins, we're left with 14. 2x plus 0 is 2x. And we're going to divide both sides. First addition or subtraction, then multiply, divide. So we're going to undo the multiplication with division. We're going to divide both sides by 2. And say 2 divided by 2 is 1. And we end up with x equals -7. Now again, it's always a good idea to go back through and check to make sure that you've gotten the right answer. We're going to plug in where that x is. Plug in a -7. Again, this isn't absolutely necessary on the test, but it's a good idea. I would do this after I had finished the test. When I have some extra time, go back through and check those that I haven't worked. You notice -8 equals -8. That's good, and moving on. Again, this is the part where you should pause, try it, and see what you get. Let's see how you did. 3/4 x equals -9/16. So what we're going to do is we're going to use the reciprocal. We're going to multiply. It'd be nice if we could get a 1 here. If we could get a 1x, then we would simply have x equals, we would have an answer. So we're going to set this up strategically. We want a 4 up here so that those will reduce to 1. We want a 3 down here so that those will reduce to 1. Well, whatever I do on this side, I also have to do to this side. So we're going to, I like to use a little dumb chart. A negative times a positive is going to be a negative. So the answer is going to be negative. Since we're multiplying across, these can be reduced. 9 and 3. 9 divided by 3 is 3. 3 divided by 3, 1. 4 divided by 4 is 1. 16 divided by 4 is 4. And just multiply across. 3 times 1, 3. 4 times 1, 4. So this is x equals -3/4. For the sake of time, the YouTube video, I'm just going to keep moving. Again, this is the point in the video where you need to pause, try the problem, and see how you did. Let's see how you did. First distribute, nope. Then combine all of your like terms. Well, we can definitely combine like terms here. We both have x's. 7x minus 3x would be 4x. And then there's only one thing left to do. We're going to divide by 4. And we're ready to go. Okay, this is a very important one. If you're going through, this is a very tricky problem, very commonly missed, and it's because of is the point in the video where you should pause, try it, and then come back. Okay, here is the critical part, this negative and the 2. We usually forget to distribute this negative onto the 2. Don't have a problem with the first part, but this is distributive property. As again, as the song says, first distribute, then combine all of your like terms. Please remember, keep, change, change, or you will get burned. And whether you actually change that definition of subtraction or you don't, you need to realize that is a negative that needs to be distributed. It's very commonly missed. So, first distribute, let's leave the 3y alone for a moment. Negative 2 times 3y is negative 6y. Negative 2 times positive 2, negative 4. So, first distribute, then combine all of your like terms. So 3y plus negative 6y is negative 3y. Please remember, keep, change, change, or you will get burned. Then get all your variables onto the same side. So we've already done that. The variables are on the left-hand side. And now we simply need to, first addition or subtraction, the opposite of negative 4 is positive 4. Negative 4 plus positive 4 is 0. That's good news. I'm moving in the right direction. And so negative 3y equals 21. First addition or subtraction, then multiply, divide, and we're trying to get, notice when we're dealing with addition, we're trying to get the additive identity, trying to get the 0. Now we're trying to get the multiplicative identity, trying to get a 1. So negative 3 divided by negative 3 is 1. And here we go, y equals negative 7. Again, on the test, when you have time, come back. I'm trying to keep the length of this video shorter, so we're going to keep moving on. At this point, go ahead and pause, see how you do, and then we'll get started. Okay. In this one, I'm going to go ahead and keep, change, change, and switch. What I'm trying to avoid is sometimes people will not realize that this is a negative, and they'll try to switch it. They'll say 2k minus 7 equals 7. Be careful. To commute these, you have to have it in a form that's addition. You have to keep, change, change, then commute them, switch them. And so now we're going to go ahead and get started. First distribute, nope. Then combine all of your like terms, nope, can't do any of that. Keep, change, change, no. Then get all your variables onto the same side. Well, they're already on the same side. First addition or subtraction, we can do that. Add the opposite of that, 7, which is negative 7. 7 plus negative 7 is 0, and same thing on this side. Now, don't freak out because you get a 0. 0 is a legitimate number. Happens. Divide through by negative 2. Get 1k equals 0, or just simply k equals 0. And this one should be easy to plug in. 2 times 0 is 0. 7 minus 0 is 7. So that does work very nicely. Okay, moving right along. Again, pause the video here. And let's get started. First distribute. Nope. Then combine all of your like terms. Can't combine them on this side. You have to do it each side. Please remember, keep, change, change. Well, we can. It's not absolutely necessary, but we will. Then get all your variables onto the same side. So we're going to do that. We're going to choose one of the sides. And you notice that we have addition here. We're going for the additive inverse property and the additive identity property, trying to get a 0 instead of this 2w. Well, the opposite of 2w is negative 2w. And what we do to one side, we have to do to the other. Which would be, addition property of equality. 5w plus negative 2w is going to give me 3w. Again, 0. And we get negative 9. Now, let's finish off. Then get all your variables on the same side. First addition or subtraction, well, we couldn't do that. Then multiply, divide. So 3 divided by 3, 1. That's negative 3. W equals negative 3. And again, check it. Come back and check it when you have a moment. Okay, so we start into a small one that has a fraction or decimal. Now, you could solve it as is. I'm going to go ahead and clear the fraction, but I've already said too much. Go ahead and pause the video. Try it on your own. Okay, the least common denominator, there's only 1, should be 7. So I'm going to go ahead and multiply by 7. The shortcut is divide by the denominator, multiply by the numerator. 7 divided by 7 is 1 times d is d, or you could say 1d. 7 times, I have to distribute to each of these parts. 7 times 5 is 35. 7 times 2 is 14. And now it's actually fairly straightforward. D minus 35 plus 35 equals 14 plus 35. That gives me D plus 0 equals 49. Okay, slowly getting harder. Pause. Try the problem by yourself and see what you did. Let's see how you did. First distribute. Then combine all of your like terms, which we cannot do here. Please remember keep, change, or you will get burned, which isn't absolutely necessary here. Then get all your variables onto the same side, which we can do. 6x, we need to use additive inverse and additive identity properties, trying to get a 0. The opposite of 6x is negative 6x. Now, you may have gotten rid of the 4x, which is absolutely fine. Doesn't matter. Doesn't matter which side you get rid of first, but you just need to choose one. 6x plus negative 6x is 0. 4x plus negative 6x is negative 2x. Then get all your variables onto the same side. First addition or subtraction. Then multiply, divide. Okay, pause, try it on your own. Let's see how you did. First distribute. Then combine all of your like terms. Please remember key, change, or you will get burned. Not necessary here. Then get all your variables onto the same side, which again, they're on the same side. First addition or subtraction. Now, remember, you can always subtract or add the opposite, either one. Depends on the context. And there we have it. Okay, try it on your own first. Okay, let's see how we did. Again, this is that problem where we don't distribute onto the second term in the parentheses. Be very, very careful there. All right, and I'm going to switch this up a little bit. I'm going to keep change, add a 1 there. in case you can't read that, negative 13 plus negative 1 onto 3h plus a negative 2. So first distribute. Again, negative times negative, positive 2. That's where most people mess up. Then combine all of your like terms. So negative 13 plus 2 is negative 11. Please remember key change or you will get burned, and that's really in reference to what we did at the beginning. Then get all your variables onto the same side. Let's see. Then get all your variables onto the same side, first addition or subtraction. Then multiply, divide. And there we have it. Okay, we're almost done. 2 more. This is a special one here. Go ahead and try it on your own. All right. First distribute. Then combine all of your like terms, which we cannot do. Please remember key change, or you'll get burned, which we, again, cannot do. Then get all your variables onto the same side, and we're going to notice that something interesting happens here. Two equals 9. There is no variable. No variable. Well, what it's trying to tell us is that no matter what I'm going to put in this, no matter what I try to place in this, for example, if you put in the number 1, you get 3 times 1 is 3, plus 2 is 5. Again, 1 plus 3 is 4, times 3 is 12. That is not a true statement. Put in 0. That's 3 times 0 is 0, plus 2 is 2. 0 plus 3 is 3, times 3 is 9. That's a false statement. Both of these are false statements. No matter what you put in here, any real number, you will get a false statement. So there is no real solution. And what do we mean by real? We mean working within the real number system. No imaginary numbers working in a billion groups, that sort of thing. And here we go, last problem for this set and for this video. Again, try it. Pause the video. And let's work it out. First distribute. Then combine all of your like terms. Please remember key change or you will get burned. Then get all your variables onto the same side. By the way, more astute students will figure out that something interesting has already happened here. And look at this right here. So what this is saying is this a true statement? Same thing that is true in the last one. Now, no matter what I put in here, there is no variable. There is no variable. So whatever happens, this is false, period, always. Well, the same thing is true here. No matter what I plug in to the original, this part is always going to be true. There's no variable. So what does that mean? This means all real numbers, or there's infinitely many solutions. all real numbers work, we'll say there's an infinite number of solutions, and uncountably many. And that concludes the video. Thank you very much for watching.